Auto Electrical and Electronic Systems Introduction. Welcome to the day lesson on the electrical and electronic system, folks. In this lesson, we will explore the advanced components and functions of electrical and electronic systems. We will also delve into repair techniques and strategies for troubleshooting and diagnosing faults in these systems. Understanding these aspects is crucial for professionals working with electrical and electronic systems in various industries. Advanced electrical and electronic system components and functions. Electrical and electronic systems are integral to modern technology. These systems consist of various components that perform specific functions, enabling complex operations and facilitating automation. 1. Advanced electrical components, transformers, devices that transfer electrical energy between circuits through electromagnetic induction. They play a vital role in regulating voltage levels. Circuit breakers, automatically operated electrical switches designed to protect an electrical circuit from damage caused by overload or short circuit. Relays, electromechanical switches used to control a circuit by a low-power signal or to control multiple circuits by one signal. Capacitors, components that store and release electrical energy used for filtering and smoothing out fluctuations in power supply. Inductors, passive components with inductance used to store energy in a magnetic field when electric current flows through it. 2. Advanced electronic components, microcontrollers, compact integrated circuits designed for specific control applications equipped with a processor, memory, and input-output peripherals. Diodes, semiconductor devices that allow current to flow in one direction only, used in rectification and signal modulation. Transistors, semiconductors used to amplify or switch electronic signals, fundamental in digital circuits. Integrated circuits ICs, a set of electronic circuits on a small chip capable of handling various functions like amplification, oscillation, and signal processing. Sensors, devices that detect changes in environmental conditions and send information to other electronics such as temperature sensors, motion sensors, etc. Auto electrical and electronic system repair techniques. The repair of electrical and electronic systems requires an understanding of both theoretical concepts and practical skills. This section covers common repair techniques used by professionals to maintain and restore system functionality. 1. Visual inspection and testing. Initial inspection involves checking the physical condition of components, looking for signs of damage such as burn marks, corrosion, and loose connections. Testing tools like multimeters and oscilloscopes are used to measure voltage, current, and resistance to identify faulty components. 2. Component replacement. Replacing defective components is a straightforward repair technique. It involves desoldering damaged parts and soldering new ones while ensuring compatibility and correct orientation. Point 3. Reworking connections. Poor or broken connections can cause system failures. Reworking involves resoldering joints or replacing connectors to ensure a secure and stable connection. 4. Firmware updates and reprogramming. For systems controlled by microcontrollers or processors, updating firmware or reprogramming can resolve software issues affecting hardware performance. Point 5. Calibration and adjustment. Calibrating sensors and adjusting component settings can improve the accuracy and efficiency of electronic systems. Troubleshooting and diagnosis of electrical and electronic system faults. Troubleshooting electrical and electronic systems involves systematic analysis and problem solving to identify and resolve faults. Here, we outline effective strategies for diagnosing system issues. 1. Symptom analysis. Understanding the symptoms of a problem helps narrow down potential causes. This requires thorough observation and documentation of system behavior during faults. Signal tracing. Signal tracing involves following the path of electrical signals through a circuit to detect where the fault lies. This technique is useful for identifying open circuits, short circuits, and signal distortion. 3. Divide and conquer. This strategy involves breaking down the system into smaller sections and testing each independently. By isolating parts of the system, it becomes easier to pinpoint the exact location of the fault. 4. Hypothesis testing. Formulating hypotheses based on available data and testing them helps confirm or rule out potential causes of a fault. This method relies on logical reasoning and experimentation. 5. Use of diagnostic tools. Various diagnostic tools can assist in troubleshooting, including logic analyzers, spectrum analyzers, and thermal cameras. These tools provide insights that are not visible to the naked eye. Executive summary. Auto electrical and electronic systems are essential components of modern vehicles, playing a crucial role in ensuring safe, efficient, and comfortable transportation. Here's a summary of these systems. Fundamentals of auto electrical systems. Auto electrical systems involve the use of electrical energy to power various vehicle components such as lighting, accessories, and engine management systems. The primary components of auto electrical systems include 1. Battery. Supplies electrical energy to the vehicle. 2. Alternator. Recharges the battery and powers electrical systems. 3. Starter motor. Initiates engine crankshaft rotation. 4. Wiring and connectors. Facilitate electrical connections between components. Electronic systems in vehicles. Modern vehicles rely heavily on electronic systems which control and monitor various functions, including 1. Engine management systems regulate fuel injection, ignition timing, and emissions. 2. Transmission control systems manage gear shifting and torque converter engagement. 3. Braking systems control anti-lock braking ABS and electronic stability control ESC. 4. Safety systems include airbags, traction control, and lane departure warning. 5. Infotainment systems provide navigation, entertainment, and connectivity features. Advanced Driver Assistance Systems (ADAS). ADAS technologies enhance vehicle safety and convenience, featuring 1. Lane departure warning and assist. 2. Adaptive cruise control. 3. Automatic emergency braking. 4. Blind spot detection. 5. Parking assist systems. Auto-diagnostic and troubleshooting techniques. To ensure proper functioning of auto electrical and electronic systems, technicians employ various diagnostic and troubleshooting techniques, including 1. Multimeter and oscilloscope measurements. 2. Scan tool and code reader analysis. 3. Visual inspections and testing. 4. Systematic troubleshooting methods. In conclusion, auto electrical and electronic systems are intricate and interconnected networks that demand a comprehensive understanding of fundamental principles, system operation, and diagnostic techniques. As vehicle technology continues to evolve, the importance of these systems will only continue to grow. Advanced electrical and electronic system components play a crucial role in modern vehicles, enhancing safety, efficiency, and comfort. Here's a summary of key components and their functions. Electrical system components. 1. Battery Management System (BMS) monitors and controls battery state of charge, voltage, and temperature. 2. Alternator converts mechanical energy into electrical energy to recharge the battery and power systems. 3. Starter motor initiates engine crankshaft rotation using electrical energy. 4. Voltage regulator regulates alternator output voltage to prevent overcharging. Electronic control units ECUs. 1. Engine Control Module (ECM) regulates engine performance, fuel injection, ignition timing, and emissions. 2. Transmission Control Module (TCM) manages gear shifting, torque converter engagement, and clutch control. 3. Brake Control Module (BCM) controls anti-lock braking ABS, electronic stability control ESC, and traction control. Sensors and actuators. 1. Camshaft Position Sensor monitors engine camshaft rotation and valve timing. 2. Crankshaft position sensor tracks engine crankshaft rotation and cylinder firing order. 3. Knock sensor detects engine knock or pinging, allowing the ECM to adjust ignition timing. 4. Fuel injectors spray fuel into engine cylinders based on ECM calculations. 5. Ignition coils generate high-voltage electrical discharges for engine ignition. Safety and convenience systems. 1. Airbag control module deploys airbags in the event of a collision. 2. Anti-lock braking system ABS prevents wheel lockup during hard braking. 3. Electronic stability control ESC helps stabilize the vehicle during loss of traction. 4. Lane departure warning and assist alerts the driver of unintended lane departure. 5. Adaptive cruise control adjusts vehicle speed to maintain a safe distance from preceding vehicles. Infotainment and connectivity systems. 1. Head unit controls audio, navigation, and connectivity functions. 2. Touchscreen display provides user interface for infotainment and vehicle settings. 3. Bluetooth and Wi-Fi connectivity enables wireless connections for phone, audio, and data transfer. These advanced electrical and electronic system components work together to create a safe, efficient, and connected driving experience. Auto electrical and electronic system repair techniques are essential for diagnosing and fixing complex issues in modern vehicles. Here's a summary of key techniques. Diagnostic techniques. 1. Visual inspection. Identify visible signs of damage, wear, or corrosion. 2. Multimeter measurements. Use a multimeter to measure voltage, current, resistance, and continuity. 3. Scan tool analysis. Utilize scan tools to retrieve trouble codes, monitor system data, and perform bidirectional controls. 4. Oscilloscope analysis. Visualize waveform patterns to diagnose issues in ignition, fuel, and communication systems. Troubleshooting techniques. 1. Systematic troubleshooting. Follow a structured approach to isolate faults. 2. Divide and conquer. Split complex systems into smaller, manageable sections. 3. Process of elimination. Eliminate potential causes to identify the root fault. 4. Consultation of repair manuals. Refer to manufacturer repair manuals for system-specific troubleshooting guides. Repair techniques. 1. Wiring repair. Repair or replace damaged wiring, connectors, and terminals. 2. Component replacement. Replace faulty components such as sensors, actuators, and control modules. 3. Programming and calibration. Program and calibrate new components to ensure proper system function. 4. System testing. Verify system operation and performance after repairs. Safety precautions. 1. Personal protective equipment. Wear protective gear such as gloves and safety glasses. 2. Vehicle safety. Ensure the vehicle is safely lifted or supported. 3. Electrical safety. Avoid electrical shock by disconnecting batteries and using insulated tools. For proper disposal, dispose of hazardous materials and components responsibly. Best practices. 1. Follow manufacturer guidelines. Adhere to manufacturer repair procedures and recommendations. 2. Use proper tools and equipment. Employ specialized tools and equipment for specific repairs. 3. Keep accurate records. Document repairs, including diagnostic steps and repair procedures. 4. Stay up to date with training. Continuously update knowledge and skills to keep pace with evolving technologies. Conclusion: mastering the knowledge and skills associated with advanced electrical and electronic components, repair techniques, and troubleshooting strategies is essential for professionals working in the field. By understanding these core aspects, individuals can effectively manage and maintain complex systems, ensuring reliability and performance in their respective industries. Remember, safety is paramount when working with electrical and electronic systems. Always adhere to safety guidelines and industry standards to prevent accidents and injuries. Thank you for taking this lesson on auto electrical and electronic system. See you soon in the next lesson. Happy learning, folks!